Okay, so we have hash null beta 1 equal to 0, and then we have hash 1 beta 1 not equal to 0. Okay, even though the hypothesis it is two-tailed test, but when we use the ANOVA, automatically the decision will be based on right-tailed test. Okay, so similar idea as a one-way ANOVA that we discussed in chapter 4. Okay, so for the hypothesis here, remember that it is not beta 1 cap because that one is a predicted one. Okay, what we need here just a parameter which is beta 1 lah, without the cap. Okay, so kalau you put cap, it is wrong lah. Okay. Okay, so if we do manual calculation, then you will have to test lah. You will have two method that you can use, which is a t-test and also ANOVA. Okay, but whenever you have the output from Microsoft Excel, automatically you will have the third method that you can consider, which is p-value method. Okay, so if the question didn't mention anything, okay, it just like perform the linearity task, then it's up to you. Okay, you can do the t-task, you can do the ANOVA, or if you have the output, then you can do the p-value method lah. Okay, but my suggestion, if you have the output, then better to use the p-value, because for me, p-value is more simple than another method lah. Okay, especially on the decision part. Okay, you can interrupt me anytime if you have any questions. Okay, so okay, I don't think that we need to discuss this one. Okay, you should already study by your own. Okay, if anything, you can just ask. Okay, okay. So the hypothesis testing for the slope using ANOVA. Okay, so as I said, similar idea as a one-way ANOVA. Okay, but the difference is the sum square value and also mean square value can be negative value. But when we calculate for the f-test by hook, by crook, it must be positive value. Okay, so means that if you have negative, the regression residual also must be negative lah. So that it will be cancel each other, and then we will get positive value for the f-test. Why do you think that sum square and mean square can be negative value? Okay, why do you think that sum square and mean square can be negative value? Anyone? Any idea? That one, this you have to know lah, so that you will not get penny if you have negative value. Okay, but when we back to the chapter 4, one way and two way, all the value must be positive lah. Okay, but for this case, sum square and mean square, sometimes you will get negative. Why? And it is okay to have negative. Why do you think that we can have negative value? Because of? Anyone? Because of the slope. Okay, because of slope. Okay, because sometimes we could have the negative slope. So that's why sometimes you will get negative for the sum square and also mean square. But by hook, by crook, f-test must be positive value lah, because we already discussed that f-test is a positive distribution. So it cannot be negative value. Okay. Okay, I just want to highlight important thing that you have to know. Okay. Okay, you should try the exercise. If anything, you can ask me. Okay. Okay, 5.4 regression analysis using Microsoft Excel. Okay, so here we have the start. Okay, if you want to explore, then you can use this node, okay, to get the output from regression, to get the output from Microsoft Excel. Okay, it is a regression. Okay, so the function, it is from data analysis. Okay, so this is the output that you will get. Okay, so I believe that you already already study all this. Okay, but just a few things that we need to highlight here. Okay, so we have the multiple R, which is a correlation coefficient. We have the R square, adjusted R square. Okay, both are coefficient of determination. Okay, but the R square here, we read R square when we have simple linear problem. Okay, simple linear regression. And we read the adjusted R square when we have the multiple linear regression. Okay, but both coefficient of determination. Okay, and then we have the standard error. Basically, we use standard error to discuss durability lah in your data set. And then we have the observation. Okay, and then we have the ANOVA. Okay, so the ANOVA here, it is similar as the ANOVA that you calculate manually lah. Okay, but here we have the significant F. So significant F, that's your p-value. Okay, so significant F represent the p-value for the whole data set. Okay, this p-value represent the whole data set. Okay, so because of so means that for the linearity task, if you want to use the p-value method, we read from the significant F. Okay. Okay, so for the output here, there is no value for the F critical. So if you want to use the F task, then you have to find the F critical value from your statistical table. Okay, that's why I said if you have the output, okay, it is easy to use the p-value method, but it's up to you. If the question didn't mention anything, then it's up to you. You can use any method that you want. Okay, you have all the available value that you need here. Okay, but if the question mentioned that use the p-value approach, then there is no choice. We have to use the p-value approach. Okay. Okay, the last table here, we call it as a coefficient table. Okay, so we have the intercept, we have the single variable here. Okay, so the difference between simple linear and also multiple linear, it is on the coefficient table. The rest will be similar. Okay, so how do we distinguish this output for simple linear or this output for the multiple linear? It is based on the number of variable after the intercept. Okay, if you have single variable after the intercept, then it is a simple linear. Okay, if you have more than one, okay, variable after the intercept, then we are dealing with the multiple linear regression. Okay, so the coefficient here we use for the model here. Okay, so coefficient of intercept, that's your beta node cap. Okay, coefficient of the number of hour here or the S, that's your beta 1 cap. Okay. One of the limitation of the Microsoft Excel, it cannot distinguish whether correlation coefficient here positive or negative value. Okay, we know that in theory the R can be negative or positive. Okay, but Microsoft Excel cannot tell us. So what we do, we need to identify by our own whether the R here is a positive or negative. So how do we identify? It is based on the coefficient of X, your beta 1 cap. Okay, so beta 1 cap, as we know, it is a slope. Okay, so slope and R must be consistent to each other. Okay, if your slope negative, R also negative. It is related to, if we sketch the scatter plot, the linear trend of your scatter plot. If you have negative scatter plot, then a negative trend of the scatter plot means that slope negative and also R also negative. Okay, because of that idea, because of that theory, if your button 1 here negative, then we read the R here as a negative value. Okay, if your beta 1 here positive, then we read the R here as a positive. Okay, so in this case, we have positive beta 1, then R also positive. Okay, so we have positive direction for the R. Okay. Okay, next you have the standard error. So standard error, we have both for the beta node and also beta 1. If you notice that if we calculate manually the t-task for the t-task method, for the linearity task, we have this formula. Beta 1 cap. Okay, we have this formula, t-task beta 1 cat divided by SE beta 1 cat. Okay, so the standard error here, the denominator of this one. Okay, so standard error of beta 1 refer to the denominator here. Okay, and the first one here we have standard error for the intercept. Okay, and then we have the t start. So t start is your t task value. Okay. Okay, so for the linearity task, we use the second one here because it is a t start for the arcs. Okay. And then we have the p-value. So this is p-value for the intercept and also for the variable. Okay, your independent variable. Okay, so the p-value of x here, it is similar to the p-value of the significant f because they are have similar purpose. Both we use for linearity test. Okay, but to be safe, you just read the significant. You just read the p-value from the significant f. Okay, to avoid any mistake lah. Okay. I think that's it that you have to know about the output. Any question so far?
No, madam.
Okay, and then we have the 5.5 multiple linear regression analysis. Okay, so as I mentioned before, for the multiple linear regression analysis, there is no manual calculation that we have to do. Okay, every value that you need, we need to read from the output. So it is important to understand the output from Microsoft Excel. Okay. Okay. The rest you can read, but I need to discuss one thing from here. Okay, the exercise 5.5. A, B, okay, A and B, you can do by your own. C, can we conclude that at least one of the independent variables is related to the dependent variables? Okay. So C, can we conclude that at least one of the independent variables is related to the dependent variable? So the idea similar as a linearity test. We need to determine whether Y and the series of X, they are related to each other or not. Okay. Okay, so D, predicted model. Okay. E, predict the value, and the F. Based on the p-value in the coefficient table, identify the significant predictor. Okay. Before that, I forgot to mention. Okay, similar for the simple linear and also multiple linear. Both hypotheses is about relationship between Y and X. Okay. So, okay. If we conclude that there is no relationship between the variables, so there is no use, or you cannot use the predicted model for the prediction. Okay, that's the rule. Okay, if we conclude that there is no relationship based on the hypothesis that we perform, okay, we conclude that there is no linear relationship between the variables, so we cannot use the predicted model that we have to predict the value for the prediction. Okay, that's the theory that you have to know. Okay. So based back to the F here, based on the p-value in the coefficient table, identify the significant predictor. Okay, so p-value in the coefficient table. So the last table in your output. Okay, it is not p-value from significant F. This is not p-value that we read from the significant F. This is the p-value in the coefficient table. Identify the significant predictor. Okay. So this is your output. Okay. So as I mentioned, this is a coefficient table. So the p-value that we need to refer, this p-value. Okay. But the purpose that we need to the purpose of this question is to identify the significant predictor. So because of intercept here is not the predictor, then exclude the intercept. Okay, do not consider the p-value of the intercept because it is not the variable. So we consider the rest of it except the intercept. Okay. How do we know that it is a significant predictor? Okay. Significant predictor, it is when your p-value significant. Significant. Okay. How do we know p-value significant? It is if your p-value less than alpha. Then we have significant p-value. Hence, we have the significant predictor. Okay. So in this question, it didn't mention what is your alpha. So we use the standard one, which is alpha 5%. Okay. So until we go to the chapter 6, if the alpha is not mentioned, then we assume 5%, the standard one. Okay. So how to answer this question? Okay, so we do one by one. Okay, one by one for each variable that we have. So x1 first. Okay, state the p-value that we have. So 0.0131. We can use only 4 decimal places. Okay, and then compare with the alpha 0.05. Significant or not? The S1.
Significant.
Yes, madam.
Significant. Because p-value here less than alpha, then significant. Then it is significant. Okay, and then we have the S2, similar process, 0.54. Significant or not?
Not significant.
No.
Not significant because p-value greater than alpha, then not significant. Okay, so the conclusion that you can make here, X1 is significant predictor. So maybe the next question, if, okay, maybe if the next question is to predict the value based on the answer from here, then means that we just use the model with y and x1. Okay, so the new model that you have here, okay, we have 0.52. Okay, because only x1 significant, so plus 0.7423. So we just use model with x1 for our prediction. Okay, because only x1 is a significant predictor. Okay. But for this question, the E ni not based on the significant predictor. So the E question here, we use the model that we write in D. So the full model. Okay. If you have the question like predict the value based on your answer in F, then we use only predictor. We use only significant predictor. Okay. Any question before we go to the 5.6?
No, madam.
Okay. So 5.6, the last subtopic for the chapter 5. Okay, by the end of this topic, you should be able to summarize the multiple regression analysis from the Microsoft Excel output. Okay, choose the most significant variable in order to achieve the parsimony model. So parsimony model means that the model with the last predicted variable. Okay. So in a real research, okay, almost all the time we do not use the model with all the predictor variable, okay, because it will affect your cost, it will affect your time. Okay, if we use or if we consider all the variables, all the independent variables, then it will affect your time of the research and also the money, okay, the cost. Okay, so that's why usually we go to the model with the less independent variables. Okay, so use the best selected model to make a prediction. Okay, when we have the best model, then we use that best model for the prediction. Okay, so simple way of the model selection. Use common sense and practical consideration to include or exclude variable. Okay, if you already well known with the with that research, okay, So if you're already expert or you have a lot of experience on that research, then you can use your common sense to include or exclude the variable. Okay, because you already have experience. If we include that variable, what happened? If we exclude that variable, what happened? Okay. So in theory, astaghfirullahaladzim. Okay, so in theory, we have two characteristics, okay, that we use to determine the best model. Okay, the first one, significant p-value. Okay, as what we discussed just now, significant p-value means that p-value less than. Okay, sorry class. Okay, so the first characteristic that we use to determine the best model is a significant p-value. Okay, so how it is significant? Okay, your p-value must be less than alpha. Okay, so significant in general, significant p-value. Okay, so significant p-value means that p-value less than alpha. Okay, and the second characteristic is the second value that we use is a coefficient of determination. Okay, so for the coefficient of determination, we need the highest value. Okay, we need the highest value. So we have R square and also adjusted R square. Why both? Because when we choose the best model, okay, we choose among the mix of the model from simple linear regression, and also there is some model from multiple linear regression. Okay, as what we discussed before, okay, for the simple linear regression, we have R square for the coefficient of determination, but for the multiple linear regression, we use the adjusted R square. Okay, but both are coefficient of determination means that they have similar characteristic. So we can compare those two value to each other lah. Okay. So in general, the best model is the model with the significant p-value and also the highest coefficient of determination value. Okay. Okay. So the step. Yeah, the step that we need to do before we do the model selection. Okay. So before we go to the model selection, first we need to know how many model that we need to consider. Okay, so the number of the model depends on the number of independent variable. Okay, so first we need to know number of model. Okay, so it depends on independent variable. So by formula, you will have to the power of k minus 1. Okay, so k is independent variable. Okay, so let's say that you have k equal to 3, which is S1, S2, and S3. So by formula 2 the power of 3 minus 1, you will have 7 models. So these 7 models, they are a combination of Y with the S1, S2, and also S3. Okay, so means that you will have Y, S1, Y, S2, y, x3, y, x1, x2, y, x1, x3, y, x2, x3, and also y, x1, x2, x3. Okay, so 7 model means that 7 different output of Microsoft Excel. Okay, so the information that we need, they are from different output. Okay, 7 models, 7 different output. You have to make sure the information that you summarize, they are coming from different output. Okay, do not use single output. Okay, because some student they use single output lah, which is not correct lah. Okay, so 7 models, 7 different output. If you have even 15 models, you will have 15 different output. Okay, in final letter, if you have this kind of question, it will be given in your question. Okay, 7 models, 7 output. Okay, sometime in final we give you a complete table. Okay, so model with all the informations that we need. Sometimes we give you incomplete table, so you have to complete by using the output that we give you in that question. Okay, or sometimes there is no table at all. We give you all the outputs that you need and then you summarize from the output. Okay, so it is important to have or to know, okay, what value that we need to extract from the output. Okay, then that's why you have to do the exercise question, so that you know, okay, this value from where, this value from where. Okay, if not, it will be problem later lah. Okay, so before you go to the final letter, please make sure that you try at least 3 set of question of the final exam question from previous semester. Okay, so that you know the pattern of the question, how, if you have model selection question, how the question would be. Okay, okay, so the information that we need to choose the best model, the first one is significant F value. Okay, that's your P value lah. The overall P value. Why we use significant F? Because here we need the overall P value. So overall P value that represent overall data set, it is from significant F. Okay. The second value, R square. So R square is a coefficient of determination for the simple linear model. So the 3 here is a simple linear model. Okay, and the third one, we need the adjusted R square. So adjusted R square, coefficient of determination for the multiple linear model. So this is multiple linear model. Okay, and the fourth one we wrote here is the regression coefficient. So why we need regression coefficient? Because when we write the answer, when we identify the best model, we need to write its equation. Okay. And then after you have this table, and then we proceed to the model selection. Okay. Okay, so after you have a complete table, then we go to the model selection. Okay, in general, the first step of the model selection is to determine the best model of one predictor. Okay. After we have the best model of the single predictor, then you can determine the most not significant model and then discard. Okay, determine the insignificant model and then discard. Okay. So the third one, after that, determine the best model of two predictor. Okay. Okay, so the best model here, it is based on significant p-value and also highest R square here. Okay, because of simple linear, and then here significant p-value and highest adjusted R square. Okay, so we continue until the best model of k minus 1 predictor. So if you have 3 predictor, then we stop at 2 predictor. If you have 4 predictor, then we stop at 3 predictor. If you have 5 predictor, then we stop at 4 predictor. Okay, at the end, in conclusion, choose the best model among the best model above. So we have the best model from here, we have the best model from here, and then we compare between the best model, which one is the best one. So that's your final answer, the best model, okay, among the models that we have. Okay, so how do we choose the best model among the best models? Similar. Okay, we compare the p-value, we need the significant p-value, and then we need the highest coefficient of determination. Okay, so here that's why I said R square here and adjusted R square here can be compared because both are coefficient of determination. So similar characteristic, they can be compared to each other lah. Okay. Okay. Any questions so far?
No, madam.
Okay. Okay. So we go to the example. Okay, so the following table summarize the multiple regression analysis for the response variable. Your y is weight and the predictor variables are height, weight, and also cholesterol. Okay, so here we have 3 independent variables or predictor variable. So you will have 7 model. Okay, so as I said, okay, 7 models means that 7 different output. Okay. And then the next question, if only one predictor variable is used to predict the weight, which single variable is the best? So if you have this kind of question, then you have to do one by one. Okay. First determine for the single predictor variable. Okay, and the next question for the two predictor variable, and then based on your answer in A and B, which one is the best one? Okay. Sometimes you could have this kind of question, or sometimes it will be straightforward. For example, your exercise. Okay, exercise that I ask you to do. Hence, determine the best regression equation for predicting the MPG value. So the answer here, the best model among the best. So straight away, you just write the best model among the best. No need to write one by one. Okay. But if your question asks you one by one, then your answer must be one by one. Okay. So you already have a complete table here. Okay. So significant F, the R square, adjusted R square, and regression equation. So already complete table, then we go to the model selection. Okay. So first choose the best model among one predictor. So we have H, W, and C. Okay. H in term of p value here. Which one or which variable with the significant p value? Which one is a significant, which variable with the significant p value? Anyone?
H and W.
H and W.
W.
Okay. H and W. Sekejap Give me 5 minutes and then I will continue. Okay, let's continue. Okay. So HW are the variables with the significant p-value because, okay, so here it didn't mention the alpha, so 0.05 lah. Okay, so both p-value less than alpha, so both variable with the significant p-value. Okay, so means that we can consider these two value. Okay, but see here the p-value greater than alpha, so means that C is not significant. Okay, based on the first value that we look at is a p-value lah. Okay, the first value that we use or the first characteristic that we use is a p-value. Okay, so by p-value C is not significant, so you can discard the C. Okay, so discard the C means that all the model with C also must be discarded. Okay, because C is not significant means that if we talk about the information that we can get, we just get a little information from the C. So it's not worth it to proceed with the model with C because only little information that we can get from the C. So it's not worth it to proceed with the C. Okay, and it's not worth it to proceed with the model with C. So that's why we can discard all the model with C. Okay, so based on HW, we know that both significant p-value, and then we need to compare the R square. So which one is the highest one? Which variable with the highest R square?
W.
W. So means that W is the best model for the single predictor. Okay, and then we need to determine the best model for the two predictor. Okay, what's left here is a HW. So automatically HW is the best model for the two predictor. Okay, of course we need the significant p-value lah. Okay, and then the adjusted R square coincidentally the highest one. Okay, let's say that the highest R square, the highest adjusted R square is at HW 0.9 here. Okay, still we cannot choose the WC because of C. Okay, so we just straight away go to the HW because the rest of it we cannot choose because of C. Okay. So then your conclusion, we choose the best model among the best. So W and HW, both p-value significant and we have similar value for the p-value. And then we compare the R square here with the adjusted R square. Which one is the best one? Which one is the highest one?
H and W.
H and W. So the best model among the best model is HW. Okay. So how do we write the answer? The best model is HW, and then we need to write the equation. It is compulsory to write the equation. If you do not write the equation, then there is no mark for you. Okay, because state the reason. Significant p-value and highest adjusted R square. Any questions so far?
No, madam.
Okay. So we go to the exercise. Have you done the exercise number 2 here? Okay. So A, identify the response variable and predictor variable. From the Excel output, summarize your result in a table. So in your module, you have the output, okay, and then summarize in a table as an example 5.9. And then hence determine the best regression equation for predicting the MPG value. Okay. So means that the C here, you can write the best model of among the best model. Okay, no need to write one by one. Okay. Okay, let's go to the answer. It's supposed to be 0.0092. Okay. Okay, so alpha is not given, so 0.05. Okay. So the first step, okay, you should have this table first lah. Okay. So the best model among one predictor between WDH. Okay. So which variable with the significant variable? Which variable with the significant p-value?
All.
All, yes, all WDH, all with the significant p-value. Okay, so we can, at first we can consider all, okay, and then we go to the R square. Which one with the highest one?
W.
W. So W is the best model. Okay, and then we try to discard the worst model or the insignificant model. So between D and H, okay, so both significant p-value, okay, but between D and H, which one with the lowest R square?
D.
D. So means that D is a worst model lah. Okay, we cannot say insignificant because it has the significant p-value, but it is the worst one because lowest R square. Okay, so means that we just get a few information from that lah, from the D. So you can discard model with the D. Okay, it's not worth it to proceed with the D. Okay, so what's left for the two predictor, the best one? So means that for two predictor, we have WH as the best model. Okay, even though it is not the highest adjusted R square, but the rest of the model we cannot choose because of the D. So straight away we use WH as the best model. Okay, even though it is not the highest adjusted R square. Okay, because the rest we cannot choose because of the D. Okay, and then the conclusion, WH and W, which one is the best one? Which one?
WH.
WH. So both significant p-value, we compare the R, sorry. We compare the adjusted R square here with the R square. So WH slightly higher than W. So WH is the best model. Okay. So the best is WH. Height adjusted R square because it is not the highest one. Any questions so far?
No, madam.
Okay. So that's the end of the chapter 5 lah. Okay, that's the end of the chapter 5. Okay, so please what we call please make sure that you really understand this chapter lah, because this chapter will be in your quiz 1 first, but just a small part of your chapter 5, quiz 1 plus quiz 5, and also the rest of it will be in final. Okay, if you go through the final exam question, okay, from the previous semester, you can see that what we call chapter 4, 5, and 6. No, the most of the mark, okay, the most of the mark of the final exam, they are from chapter 4, 5, and 6. Okay, we have about 70 to the 80 over 100 coming from chapter 4, 5, and 6. Okay, so that's why I think I already said before, if you want to score final, then make sure you score chapter 4, 5, and 6. So focus more on the chapter 4, 5, and 6. Okay, because as we know that 4, 5, and 6 is more simple than chapter 2 and 3 lah. Okay, so chapter 2 and 3 also will be in final, but we just have about 20 marks plus for the chapter 2 and 3. Okay, the rest from chapter 4, 5, and 6. Chapter 1 will be everywhere because it is a theory that you have to know about applied statistics lah. Okay, means that the type of variable, the level of measurement, something like that lah. Okay, but there is no more calculation from chapter 1. For example, box plot lah. There is no more box plot or any calculation from the chapter 1. Okay, just a theory that you have to know. Maybe it will be asked in the question of chapter 6, like that lah. Okay. So for the final preparation for the final, because next week is the last week for this semester, and then you will go to the study week and then the final exam week. Okay. So preparation for the final, focus more on the chapter 4, 5, and 6. That's why it is important for you to really understand, okay, the chapter 4, 5, and 6. Okay, so how to grab the idea, how to understand those chapters, there is no choice lah. You have to do the exercise. Okay, you have to practice. Okay, do the exercise question, do the tutorial questions, and also before the final, please make sure that you try at least 3 to 4 set of the final exam question lah, so that you will get, okay, the pattern of the final exam question. questions. Okay. So focus more on the 4, 5, and 6. Chapter 2 and 3. You can try lah. Okay. But please make sure that you can score 4, 5, and 6. Okay. So that if you want to score final exam lah. Okay. Okay, we proceed to the chapter 6. Okay. So the last chapter for the applied statistic, we have goodness of fit and contingency table. Okay. So what we call this chapter, the data used in this chapter, it is a qualitative data. Okay, qualitative data. Okay, so what you have here is a frequency of the qualitative data, frequency of the categorical data. Okay, so we have 3 subtopics for this chapter: goodness of fit task, okay, goodness of fit task for categorical data, and then we have fitting of the distribution. Okay, and then we have contingency table, testing for the independence between 2 variables and test of the homogeneity proportion. Okay, and the third one, you have the goodness of fit and contingency table using Microsoft Excel. Okay. Okay. But we not highlight, or we not stress on the goodness of fit and contingency table using Microsoft Excel. Okay, but still we have on the note, then you can go through the note. Okay, for the 6.3. Okay, we stress more on the 6.1 and also 6.2. Okay. Okay. Okay, so the outcome here, test the goodness of fit for the categorical data. Test whether the categorical data fit to the certain distribution. So we have the binomial, Poisson, and normal distribution. So use a contingency table to test the independence and also homogeneity of the proportion. And we have the application of Microsoft Excel to solve the goodness of fit test and also independent test. Okay, so 6.1 goodness of fit test, GOF. Okay, by the end of this topic, you should be able to apply the goodness of fit test for categorical data. Okay, so categorical data here, it is a qualitative data. So what we have again, it is a frequency of the qualitative data. So test the data whether fit to the binomial, Poisson, or normal distribution or not. Okay. Okay, so the test is applied when you have one observed variable from a single population that can be categorized. It can be used if there are more than 2 categories. Okay, so the data is from single population and the variable that can be categorized. So let's say that we talk about the method, then you will have more than 2 methods. Okay, if we talk about the color of the candies, it must be more than 2 color. Okay, if you have single color, if you have single and double, 1 and 2 categories, then we back to the chapter 3, which is proportion. Okay, you can use the parameter proportion to compare. Okay, because for the qualitative variable, the parameter that appropriate to use will be the pi. Okay, so one of the assumptions for the goodness of fit is you need to have more than 2 categories. Okay, so for the goodness of fit, we will use the chi-square test. Okay, so similar when we go to the contingency table, the whole chapter 6 here, it is about chi-square test. Okay, so chi-square test is used in the GOF to compare the observed frequency in the sample with the expected frequency. Okay, the frequency obtained from the actual performance are called the observed frequency, while the frequency that we expect to obtain are called the expected frequency. Okay, basically the value of the expected frequency is calculated based upon the claim distribution. Okay, the data given. Okay, the data given in your question, that's a actual performance. Okay, we call it as an observed frequency. Okay, the frequency given in your question, actual performance. And then we need to compare actual performance with the expected performance, or we call it expected frequency. Okay, expected frequency we need to calculate based on the distribution given. Okay, distribution given in that question. Okay, for the 6.1.1 categorical data, distribution of your data will be based on percentage, will be based on the ratio, or it will be based on the category number of category of your data. Okay, but when we go to the fitting of the distribution, your distribution will be normal or Poisson distribution, or what we call binomial distribution. So you are given observed frequency, we need to calculate the expected frequency based on the distribution given, and then we compare the performance of we compare the actual performance, which is your observed frequency, with the expected frequency. Okay, we need to see whether the data that we have fit or not to the distribution lah. Okay, so this is the the assumption of your GOF. Okay, the data obtained from a random sample, the variable under study is a categorical data. It is only qualitative data, not the quantitative data. The data is an observed frequency. Expected frequency for each category must be at least 5. If the expected frequency is less than 5, combine the adjacent categories. So that one we will discuss later. Okay. So when to use, when we need to compare between observed and expected frequency for a certain categorical data. And then the second one to determine whether the observed frequency for an experiment follow a certain pattern or not. Okay, that's 6.1.2 lah. Okay, so this is how we calculate for the GOF. Okay, goodness of fit task. Okay, for the categorical data. So O here given in your question, we need to calculate the E based on the distribution given. Okay, the formula of the E is NPI, N number of data, the whole data that you have, or it is actually by formula N is a summation of OI. Okay, if not given, then you can calculate from observed frequency. Okay, and PI is a probability. So this probability coming from distribution of your data. Distribution of data. Okay, so we have K here, number of categories, and then we have the new letter lah, that one. Okay. Okay. So the hypothesis. Okay, this is the fit hypothesis for the goodness of fit for the categorical data. Okay, HNA, it will be always, there is no different, there is no change, there is no preference of your data, or there is a different, H1 opposite to that lah. Okay, there is a different or change or preference of your data, or you can state the claim of the categorical distribution. Okay, if you have percentage, then you can state the percentage here. That's the distribution. Or you have ratio of your data, then you can state the ratio. Okay, or let's say that you have number, just a number of category, then you can state that lah, okay, based on the question. Okay, Hashna, it will be always claim of the categorical distribution, and H1 opposite to that lah, okay. Okay, so the procedure, okay, so state the hypothesis as usual. So we still have 5 start because of hypothesis testing. So compute the test statistic, but before that we have to do something lah, okay. And then find the critical value. Okay, for the whole chapter 6 here, it is about right t-test. It is something to do with the chi-square is a positive distribution. Okay, so your decision based on right t-test for the chapter 6, the whole chapter 6. So you will have chi-square alpha k minus 1. Okay, so k minus 1 is your degree of freedom. Okay, and then decision is based on the right t-test, and then step 5 is draw a conclusion to reject or accept the claim. Okay, any questions so far? Any questions so far?
No, madam.
Okay, so this is the characteristic of the good fit, and also here is a not a good fit. Okay, usually after you done with the hypothesis, the next question might be whether you have a good fit or not a good fit lah. Okay, so good fit means that your chi-square test value will be small. How do we know it is smaller? So chi-square small when decision is do not reject Hashna. So means that they are close to each other. Okay, means that observed value and expected value, they are close to each other. So we have a good fit lah. Okay, a good fit. Okay, because when we compare the actual performance with the expected performance, we need the actual performance close to the expected performance. Okay, because the expected performance, it is based on the distribution given. Okay, so the actual performance need to be close to the expected performance. Then, so that it is a good fit lah. Okay, if your chi-square value large, means that the decision is reject Hashna. Okay, so reject Hashna means that observed value far from the expected value. So it is not a good fit. So we do not want that kind of situation lah. Okay. Okay. Okay, I ask you to do the exercise 6.1.1 number 2. Okay, 5:30 already, almost 5:30. I cannot focus anymore. Masalah dunia banyak sangat ni. Can we continue next week? The rest of it?
Boleh, madam. Saya pun tak fokus ni.
Yes, madam.
Okay, so
Okay.
next week we start with the exercise 6.1.1 number 2 until the end of the chapter 6. Okay, so don't forget that. Ya, kejap. Don't forget that we have quiz on Monday. Quiz on Monday. It is salah dunia ni. It is your quiz class. Okay, so 5.1 and 5.2. Okay, so That's all for today, class. See you next week. Inshallah, take care of yourself. Be safe. Thank you, class.
Okay, madam. Okay,
Thank you,
madam.
madam.
Bye.
Yeah.